Welcome to our session. My name's Hugo. This is Oren. We'll do quick introductions shortly. In today's session, we're covering designing modern applications on VCF 9. So hopefully, Monday and Tuesday this week, you've had time to digest all the great new information around VCF 9, because I'm not going to repeat any of that in this session, because we're focusing on the layers above VCF 9 and even the organizations, regions, zones. Those words hopefully sound familiar. Hands up if you're okay with what I just said. Okay? Wow, we got a good start.
Yeah.
Okay. So Oren and I will just focus on how you can consume VCF 9 from what you've learned over the past couple of days in order to design and deploy modern applications onto this great new platform that we have. Okay? Quick stuff about me. I've been with VMware for a number of years, all the way back since 2010, on and off, and been doing lots of stuff within cloud, within Tanzu, in Oren's organization, and now I'm focusing on architecting modern applications on VCF. So if you want a more detailed discussion, just catch me after the session. I can help you out here. Oren?
Raul?
Oh, sorry. Raul couldn't be here today. I wanted to showcase he did a lot of work on the demo that I'll play later, and that's the demo that Raul recorded for us.
Hey everybody, I'm Oren Penso. I'm the Global Field CTO in the Tanzu division. I'm in VMware for 10 years doing cloud native, Kubernetes, Cloud Foundry, anything around that kind of application modernization landscape. And I'm happy to be here and share some of the information about the path of productions and the different options that you have.
Yep. Okay, so disclaimer slide, I think you've seen this all week, very, very important. What we say today, I think, is all available software. So there's no roadmap or anything. You can literally just deploy it today, consume, and use as it is, all right? So I just want to start with a state of production Kubernetes, because this session is around how to get from code, in your view, code, and then how to get to production as quickly as you can. So if you want to grab that link there, it's the Spectral Cloud Report. I think it was released about a couple of weeks ago. Just details some of the key highlights of where the industry is today and how VCF can help you deliver on these things, right? So for example, private AI, there's 92% said they were investing in cost optimization tools. Oren will talk to you about some of the AI capabilities on VCF, not just on Private AI Foundation, which is what we have a great relationship with NVIDIA, but also using some of the Tanzu capabilities on VCF to deliver private AI, right? So I'm not going to drain this because we have better things to show you. So how does VCF enable you to design and build modern applications with the tooling and tool sets that you have, right? And it all comes down to this great technology that we have within VCF, which you enable supervisor services, all right? So supervisor services are key to enable modern infrastructure as a service capabilities. So let me go into that in a little bit more detail here. So on the top left, is it this one? Yeah, here we go. You have the runtimes, right? So you have VKS runtime, which is a Kubernetes cluster that is deployed into your VCF workload domains. Then you also have the VM service. Think of it as deploying virtual machines and managing virtual machines with the same API that you're using for deploying Kubernetes clusters. So it's basically Kube API deploying both Kubernetes clusters and virtual machines. And the third runtime is, of course, vSphere Pods. So vSphere Pods is not a new technology. We've had it since vSphere 7. vSphere Pods just containers running directly on the ESX hypervisor. All right? And many of the services that you see on the right-hand side are delivered as vSphere Pods. So these are containers running on the supervisor service. All right? The infrastructure services out of the supervisor enable you as an administrator or your consumers to consume network services such as load balancing, such as ingress, right? Such as cloud native networking within your pods and Kubernetes clusters. You also have storage services provided by vSAN, for example, right? You note that in the keynote yesterday, Paul described S3 capability coming out of vSAN. That's a particular service that will be available soon as well. And then on the right-hand side, of course, if you're building and designing modern applications, right, microservices-based applications, true applications that are modern, not a monolithic virtual machine that you virtualized, put into a container, and then run in a Kubernetes cluster. That is not a modern application. We'll talk about applications that you split up and have multiple microservices, which I'll describe in the demo shortly. You need these additional cloud services to provide those capabilities, right? So let me just go through some of these. You have Kubernetes Management Service, which is a multi-cluster management service. You can see there's 2 asterisks there because at the moment it's not available, but it is going to be available within the next quarter. That enables you as providers of a IT service to your business to manage multiple Kubernetes clusters at scale. Let's say you have 5,000 Kubernetes clusters, right? You're not going to be doing ClickOps. You're probably going to be doing some kind of Terraform or YAML, but then even that, you need policy management on top, right? So you want to set up backup schedules for multiple clusters, for example, or you want to define that these sets of clusters can only access a particular registry for security and for compliance reasons, right? Then we have the other services, Harbor Registry for private registry on-prem, Istio Service Mesh as well. So this is something that's new within VCF 9, allows you to enable MTLS communications between pods and clusters within the platform. So some of these services are in the demo. Harbor, Istio, Argo CD, Contour, Cert Manager, and yeah, those are the ones that I'll be showcasing in the upcoming demo. So Oren will take you through this part here. Oren?
Yeah. So we've talked about a lot of different services, infrastructure services and runtime services. One of the services that you have in the VCF stack as advanced service is a platform as a service. A platform as a service allows you to push the code and not think about anything else. I will extend in a couple of slides. But we are aligning the platform into the same structures using the same services that Hugo just mentioned and explained. So the platform itself is relied on the same services and the same infrastructure components using the same structure of logical boundary and tenancy to create that kind of an application space for a developer. And I will showcase and demo later on what is the developer experience on the PaaS and how can a developer consume that kind of an application space to take that code and push it into production, either change it or push it directly into production. So I think one of the things that is important to understand here is that we are not saying what's best for you. We are saying that like any other public cloud, you have a lot of different services. You have Kubernetes services, you have platform services, you have data services, you have different ways to do things because of different use cases. And this is how we're gonna present the platform as a service path to production. But there's also, again, the container as a service, the CaaS path to production. Now, I'm not a coffee guy, but that's the best way I can explain those two different paths to production, right? As one that doesn't know anything about coffee, I'm gonna be very struggling with the left one, which is the Bianca V4 something, because I'm not a coffee guy. But there's a lot of switches and knobs, and you will need to know what's the grind level and what's the pressure and what's the temperature. And for someone who knows what he's doing, you can get an amazing cup of coffee that is right for you, that you can control up to the point of the last grind of the coffee, right? And that represents the CaaS path to production. You can configure everything. right? The service mesh, the policies, the data protection, the way that you're building the code, everything. On the right side, you have my own coffee machine. That's mine. Because I don't know anything about nothing that is related to coffee. And that's the Sage Touch Express. I'm pressing a button and I'm getting a coffee. Now on the right side, Sage is a coffee maker company. They know what the pressure should be, what's the temperature should be, what's the grind level, how much time the water should be spilled on the coffee so I will have a great coffee. And again, I couldn't care less. Like, I won't understand the difference between the two. But that's the PaaS. A PaaS is a solution. It's an advanced service that will allow you to just click on a button, CF push your code, and it's going to run on the other side. Now, again, I'm not saying what's better. For someone who really loves coffee and knows about coffee, the Bianca is amazing. And maybe that's the way to go. But just so you know, there's another option and there's another way to take that kind of code into production. Now, there's pros and cons in each and every one of them, of course, and we will try to emphasize that as part of the demo and as part of the discussion. This is the demo environment that we will show you, right? And as I said, there's different ways to go to production. On the right side, you can see a developer that is basically managing the code in source control with GitLab. Our environment is an internal environment. It's inside Broadcom, so nothing is using anything on the cloud or any public resource. Source control in GitLab, GitLab runner that will actually build upon commit, upon change. Then Harbor will be the registry where we are pushing the container images to. Once the container image is in Harbor, now we are triggering a CI, a CD process with Argo CD. Argo CD is one of the services that can run directly on the supervisor cluster, just like Hugo said. And that Argo CD will basically take that desired state with the image from the Harbor, and it's going to make sure that it's going to run on Kubernetes based on that desired state. That's the CaaS path to production. This is something everybody in this room should know something about, because I'm sure all of you have some kind of this kind of path to production. Now, I'm sure that you have more than one. I'm sure that you have thousands of pipelines running in your organization, and one of them will probably going to look like that. The other side, which is the PaaS side, the same developer will take the same code and it will run one command, CF push. And that CF push will take the code and it will just push the code and it will expose the app. CaaS versus PaaS. The difference is that in PaaS, I'm not the one to configure what is the load balancer, what is the registry, how it's going to look like when it's connected between the different dots. No, the PaaS is responsible for everything. I will have eventually the outcome, which is the application itself. But that's the demo, and we will start with CaaS. So a bit about, like, one sentence about Tanzu and what's our mission. I think it's very clear from what I've just mentioned and like the intro that I did. But our mission is to drive business velocity by accelerating the idea to code to production. And the way that we think we can do that is by injecting opinions. Without opinions, you have too many options. When you have too many options, you have too many integration points. Too many integration points, too much complexity. Complexity, slowness. If you have opinions, everything shrinks down into a consistent way to take the code into production, and that makes things faster, right? That's our mission in life. If you want to talk about, like, or understand the difference between IaaS, CaaS, and PaaS, that kind of a map shows the thing, right? When the abstraction is obvious, when you do virtual infrastructure, your stops in the OS, you're creating a VM, right? Everything else, someone else will do. When you do IaaS or CaaS, it's not just the OS, because now you have also the containerization, and you have the containerization management, orchestration, which is Kubernetes. But then on top of that, it's someone else's problem, right? Middleware, API gateway, the way that you're building the app, the pipelines, and everything else. On the platform as a service, everything is being taken care of by the platform up to the costume code. So the only thing the platform engineer needs from the developer is the code itself. Push your code. And that's it. Does that make sense? Any questions on that? I think we can start the demo.
Yeah. Okay. So just before I start the demo, all the code for the CAS side, Container as a Service, which is the Argo CD, GitLab, etc., you can find on Rahul's GitHub page. So take a screen grab. Also, the links on the slides that you'll get at the end of the event. But if you want to follow through, because the demo might be a little bit small on the text, but don't worry, the code is legit. But if you want to see the code, just put it on your devices now. So I want to talk to you about this e-commerce application, right? So it's an e-commerce application that we're using. It's got a bunch of microservices, ad services, cart services, shopping services, email services, etc., right? Everything that you need to deliver an application that enables you to run your business, okay? Now, this is how it looks if you were using AWS's public cloud services with EKS, EC2, application load balancers, and so on. What if you wanted to take this application and run it on-prem, right? Could be data sovereignty issues. You want to keep everything private inside your own data center, just as an example. On VCF 9, this is the exact equivalent, right? So you have your pipelines, which you've already used in AWS. By the way, you can actually replace components. You don't have to use GitLab, GitHub, Jenkins, Ansible. You can use whatever you use today. Because we're providing the same APIs that you're currently experiencing in your public cloud anyway, all right? Now, the Kubernetes cluster is, of course, VKS. We should also have the VM service if you want to run virtual machines instead of Kubernetes. We also have that pod service if you want to use pods directly on ESX server as well. Then we have Argo, which does the CD component. We're using GitLab for the CI, Harbor, instead of the Elastic Container Registry that you have in AWS. And then NSX or Avi for the load balancing, and so on and so on. So what I am saying here is you can run whatever you have without much change. Let's say you had a Helm chart that you're using AWS. You can pretty much reuse that Helm chart on-prem with a few changes to the manifests. Make sense? Okay. So this is the GitOps demo architecture that I'm going to showcase now when I press play on the demo. So there are three personas, as you can see. Platform engineer, which I believe majority of the folks in this room are. I've noticed a few faces. One or two of you are the actual developer persona. And then we also have the end user at the top right who consumes the application, right? Who logs into the web page, goes to the e-commerce website, orders some products, gets it delivered to the house. So before we get to that stage, so the demo, the PE, which is Rahul in this case, Rahul creates the Terraform files, and then he deploys a Kubernetes cluster provisioned through the VCF 9 automation capability. And then at the end of it, he gets a VKS cluster, right? So a Kubernetes cluster running in VCF 9 with all of the key services like CNI, CSI, all of the capabilities that you need to run this e-commerce application. What we can also do is just take these files, stick them in the code repo, and then do a CD, right? And CI even. So if you wanted to, for example, increase the number of worker nodes, you can just change that in the code and it will just deploy, right? Or update. Then when it comes to the developer, we've got the code repo. So the developer has Visual Studio Code, right? He makes a change to the code, commits that code. It gets sent to GitLab. GitLab goes through the CI pipeline to create the Docker images, pushes that to the Harbor registry, and then Argo is monitoring any changes to the code and then making the continuous delivery into the VKS cluster. So this is how the demo works, and we'll show you now, in fact. So if I come here and change, Thanks, Oren.
This is the Terraform code to deploy the VKS cluster. As you can see, I'm using the VCFA Terraform provider, which is a version 1.0.0. Along with it, I'm also using the native HashiCorp Kubernetes provider. In subsequent block, I'm initializing the VCFA provider with the details of VCFA platform like user, password, URL, organization details. And in the bottom, I have initialized the Kubernetes provider. This is the main.tf file where I am using the data blocks to read the value of VCFA organization, VCFA reason, and the storage class. And this is the main VKS cluster resource block. I have defined the pod sider, service sider. I'm using the built-in generic version 3.3.0 cluster class. And the Kubernetes version I'm using in this demo is 1.32.0. This is the variable files where I have defined the variables necessary for this deployment to work. And this is the terraform.tfr files where I have defined all these variables values. I will first clone this repository. First thing I will do, initialize the Terraform providers. When this is initialized, I will do a Terraform plan to see what this is being deployed. Since I have only one resource block defined, which is VKS cluster, this code will deploy one resource. Now I'll go ahead and do a Terraform apply. This code is reading all the data blocks which I had defined the code and creating the VKS Kubernetes cluster of version 1.32.0. As you can see, deployment is succeeding. Now coming to the CI/CD part, in GitLab I have two repository named microservices-demo, which has my main application code. The another one is helm-charts, which is synced to the Argo CD. In microservices-demo, this is my GitLab CI pipeline, which has two stages, build and update. Build stages is going to create the Docker images. Once it creates the Docker images, it's going to upload those Docker images to the Harbor repository with the latest commit ID. And the update stage is going to update the values.yaml file in another GitLab repository with this latest Docker tag. I have triggered the CI pipeline. First is build stage is running. I'm using the local GitLab runner for the CI pipeline. This pipeline has started getting the Docker images and pushing those Docker images to this Harbor repository under the test-repo. As you can see, images are being pushed. This job build has completed. I can verify by quickly jump to the Harbor repository. All my 13 Docker images are available with the latest tag as commit ID. So my pipeline run is successful. I can quickly jump to the other GitLab repository to see if the images are updated with the latest SAW values. Let me go to the values.value.yaml file. And this is the latest commit ID. On Argo CD, I don't have anything defined yet. I haven't created any application. What I have done is in the repository section, I have updated my both Git repository and the cluster which I had created, I have added to this Argo CD instance. Now what I'm going to do, I'm going to create an application. Let's call this demo-app project. I'm using the default project. And now I am keeping the sync policy and manual. And the repository, I'm going to select the help-charts. That's where my help charts is. In the path, I'm giving the root path. That's where my values.yaml file is. The cluster URL, this is my VKS cluster. and I'm going to deploy everything under the default namespace. On Argo CD, I don't have any application defined yet. What I have done is added the GitLab repository. This is the repo which has my Helm chart for this microservice application. And I have added the Kubernetes cluster which I had deployed via Terraform. Now let's go ahead and create an application. I am giving the name like demo-app. I'm using the default project. For now, I'm keeping the sync policy as manual. The repository, that's the only repository which is added to the Argo CD instance. Path, I'm giving the root. That's where my values YAML file is available. This is my Kubernetes cluster. I'm gonna delete this application in default namespace. Let's go and quickly verify. I don't have anything in my default namespace. Now I'm gonna go ahead and create this application. The app is created. Since I had created this app with this manual sync policy, what I'm gonna do is click on sync and synchronize. The moment I am clicking on the synchronize, what it's gonna do is gonna pull those Helm charts available in my this repo and deploy in the default namespace of the VKS cluster. It has started creating the services for all 12 microservices like add service, cat service, checkout service, and currency service. These are the pods. So it took a few seconds for this application to become healthy. I can quickly verify in my Kubernetes cluster. All my pods are deployed. Now, you might ask why these are 2 by 2. Because I do have a Istio service mesh installed in this cluster as a package. I can quickly show you the VCF package install list. -A. As you can see, Istio is installed as one of the package on these clusters. So Cloud Proxy pod is also up and running. I don't have any ingress created yet. I'm going to leverage the Istio ingress gateway to export this application outside this cluster. And this is the YAML file where I'm creating a gateway with the name frontend-gateway. This is my ingress gateway selector, and hostname I'm using this as an FTDN for my application online-boutique.sfo.rainpole.io. Along with the gateway, I'm creating the one virtual service. Let's go ahead and apply. It has created the gateway and virtual service instance. What I'm going to do is test my application if this is available on. As you can see, my application is accessible outside the cluster using the Istio ingress gateway. Now let's imagine this online boutique store application just got featured on a popular tech blog and the traffic is surging. Now I need to scale my application to keep up with the demand. All I can do is I will simply scale the replica count of one of my service. Let's say I'm going to ahead and increase the replica count of the checkout service. And since I have Helm chart in another GitLab repository, Helm-charts, I will go ahead and scale the replica count from 1 to, let's say, 3. Save this file. And push the change to GitLab repository. Now typing the commit message. Now Visual Studio Code is committing and pushing the changes to the GitLab repo. So updates have been pushed to the repository. Now in the Argo CD application, I need to do a refresh. Since I have the manual sync, I didn't select the automatic one while creating this demo-app application. I will go ahead and synchronize the changes. But before that, let me show you how many pods are running. So now only one pod is running for this checkout service. The moment I'm going ahead and synchronize the changes, what Argo CD gonna do, it will deploy 2 more pods to meet the desired state, whatever I have configured in the GitLab repo. If I run the kubectl get pods command again, you can see 2 additional pods were deployed for this checkout service. And this demonstrates how you can scale the microservices application to meet with the demand.
Cool. So I hope that I try to keep the demo, very, very simple. We could have automated everything end to end, right? Like automatic synchronization, using cluster autoscaler, using a number of tools to, scale out microservices that need more scalability. So with that, next demo is Oren. Oren's going to show you the PaaS, so path to production with PaaS, and that's the architecture there.
Yeah. So what we saw in the first one was a code that is managed inside GitLab, and then the runner that basically compiled and built it, created the image, Harbor, and everything else. What we're going to see now is we're going to see a developer interacting with the platform as a service. The platform as a service for the developer is nothing else than an API endpoint he can log into. Once he logs into that API endpoint of the PaaS, he gets access to an application space. That application space, don't mix up that with a Kubernetes namespace. That's not a Kubernetes namespace. It's a platform as a service application space. And that platform as a service application space, or the Tanzu application space, will allow that developer to then just point his code and push his code. What will happen in the back end is everything you saw in the CAS, but it's not going to be in the front end. The operator or the developer won't go in and see all the different files. You saw that there was a lot of configurations, YAML files, different UIs, different tools that we used for the CAS. In the PaaS, it's only one. It's only that API endpoint the developer is using, and then one API endpoint or UI that we are managing everything through. So yeah, let's go. I need to log in again, just a second. Okay, so I'm the developer right now, and I just want to show you like the structure for a second, so you can understand like the architecture behind the scenes, right? So, did we promise we wouldn't go there? Yeah, just one sentence.
Yeah.
Because I want to. If as the developer, I won't see any of this thing, right? I just want you to see that it's aligned with what the actual developer is logging into, right? So there's an organization, which is Rainpool. This is the organization that we are talking about. And inside of that, there's a project that the developer will get access to. In that project, he will have access to a specific space, and that space will allow him to deploy the AI application that I will deploy. So now I'm in full developer mode, and I'm in my IDE. A developer shouldn't get out of this context, right? Like a developer should code. What's the most expensive resource in IT? Humans, developers, right? We want developers to focus on code, not to focus on YAML files, configurations, or anything else. So I'm on my IDE, and I have my application code here, and I can obviously change things, and we will push a change just to show that. But I also am connected into my PaaS. So when I'm connecting into my PaaS, I can see that I'm not in the right organization and space, so I will just change that for a second. Okay, so I'm connecting now to project 02, which is the project that we've talked about that the user, the dev, has access to, and this is the application space that I will push my application to. Now, as the developer, again, the only thing I need to know is that I'm pointing to the right space, which is the one that I'm logging into, and then I'm doing CF push. Now, everything that will happen right now is exactly what you saw in the CAS, but it's not a fragmented process, it's one. It's compiling, it's building, it's storing the droplet, AKA image or OCI image in Kubernetes, and then it's pulling it and running it inside that application space. Now, you remember all the Istio thing? So the PaaS has also a service mesh integrated inside of that, built on the same structures as Istio, but it's, again, managed by the platform. So once the application will run, I will already have an URL that I can browse and I can test my app, see if it works or not. Now, in the meantime, because it's going to take a couple of minutes, I'm going to show you the UI that the developer has access to. And the developer, when he gets into the UI to his project, he sees his spaces, that's his space. And inside his space, he can see the application that is running. Those are the applications that I pre-pushed. Again, we don't have a lot of time for this demo, so I won't be able to show you everything. But those applications are already running. One of them is the AI tool chat, and I can see a lot of information on the application itself, including logs and revisions and everything you should know as a developer on what's the health state of the code in the app. I can obviously also scale up, scale down, auto-scale, and I can click on View App, and that will actually open the app. Now, the application here is a super simple application of a chatbot, but to have a chatbot working, I need a service. I need a large language model. And what the platform has built in inside of it is what we call a marketplace. That marketplace allows me to publish services inside of that marketplace for the developer to consume in a self-service manner. So I don't need to open a ticket as a developer. I don't need to ask anyone for permissions. I've already pre-approved a list of services that the developer can use. And now when the developer is opening up his marketplace, clicking on new service, it will see only the services that I'm allowing that developer to create. Again. Now, you can see Postgres, you can see Redis for cache layer, you can see GenAI for Tanzu platform. GenAI for Tanzu platform allows me to expose models, LLM models, internally or externally as a service for the developer, which means that those models that you see right now, the chat models and the embedding models, those models can run either internally inside the platform on CPU or GPU. The platform can also connect to vPave with all the models that will run on vPave, but the platform can also connect to external resources, OpenAI, Anthropic, AWS Bedrock, Vertex, Azure OpenAI, right? So we have an AI middleware as part of the platform as a service, as part of the Tanzu platform, that allows you to expose services to the developer, and the developer doesn't need to think about anything. The only thing he needs to know is to get into that marketplace, choose a service, and then create it. Now, again, I pre-approved and I've pre-created a service for the chat. Now, this service is running a Qwen chat plan on the CPU. It's a closed box. It's even more than a closed box. It's a nested closed box. So I will run an LLM model on CPU on a nested VM that is running on a physical one. Let's see how it goes. So this is the chat, and you can see that I've connected to my Qwen 2.57 billion model. And if I will say hello, and I will go have some coffee and some biscuits, eventually I will get an answer, because that's, again, running on CPU. Now, there's a reason why I'm showing you that, even though it's so slow. The reason I'm showing you that is because as a developer, I don't care how much time it's taking. Like, I've just created a chatbot. I want to know that it's working. I want to know that it's able to communicate with an LLM. In production, I won't push it into production directly either way. It's not gonna be that model for sure. It's not gonna be that app even, right? So right now it's being pushed, so that's why I don't have any access. So we need to wait for the application to be pushed. Okay, it's pushed. Let's see now. We need to restart. and after the restart, it should work. So one of the things that we are allowing our developers to do also outside of creating the service is what we call a bind service. Now that's even more important than the create service. A developer by himself can create a service, that's fine, but now how he connects that service into the application, right? The application needs the credentials, the configurations, all the connection string to connect to that service. The platform is taking care of that for you. So once the developer is doing a bind between a service and an application, all the credentials and the configuration is being injected into the application, and then you need to restart the application, so the application will spin up with all the information so it can connect to the services. So right now, it's still being restarted. Questions in the meantime? Because we need to have
Coming from Azure Spring Apps, that is kind of deprecated right now.
Yeah.
And you guys have support for it.
Yeah.
So in this case, they provide a service registry and a config.
You have it here. Everything you have in Spring Apps, in Azure Spring Apps, came from here. This is the origin of Azure Spring Apps. By the way, this is the origins of Kubernetes as well. It was before Kubernetes. Yeah, because I didn't implement it. There you go. And it was fast. I didn't have to go to a coffee. That's just a simple example, right? And again, it's a simple demo. It's a short one. It's just to show you the difference between the different paths to production. So what have we seen here? We've seen the VCF 9 stack with all the new innovation from VCF 9. We saw two different paths to production. One that is leveraging all the Kubernetes structure with all the innovation of Kubernetes and supervisor cluster with all the services, and the capability of creating a CI/CD pipeline from code into production based on those Kubernetes structures with VKS and VCF. From the other end, we saw the second option of path to production, which is a platform as a service, where you just need to present your code and the application will run. Everything is opinionated, everything is consistent, two different ways to take your code and go into production. And I think that's it.
Well, yeah, so just quick one. Hands up if you're thinking about doing container as a service with the CI/CD pipelines that you saw today. Yeah, 1 or 2, 3, maybe 4, 5. Okay, good. What's for the others? What are the blockers right now, Carsten or Steam? Just developers getting on board, or? Okay.
We are CSP, so we talk with customers and want to build our platform.
Okay, yeah.
So for us, it's
Nice to have, yeah. So I guess what you can do is build what I demonstrated. You have the code, give it a go, try it out, build the supervisor services, and give it to your developers and say, hey, this is an option for you, it's a service you can offer. And then on the other side, on the platform as a service, you can get that deployed into VCF as well. So you have the best of both worlds, really, the two coffee machines, right? Yeah. For those who don't know how to build or who's not a barista, right? You can just press a button on the simple coffee machine and your application gets deployed. Alternatively, if you have baristas in your organizations, highly skilled, highly capable folks, you can do it the other way as well. So it's up to you. And VCF, of course, supports both.
I mean, it's like that in the public cloud, right? Public cloud has all of those services and options. You should have the same in the private cloud, and that's exactly the point.
Yep. So please take the survey. Thank you for coming and enjoy the rest of the show.
Thank you very much.